Major web is coming down. The top kind of confusing, yes or no? Right? What must it be? Right? So you know that there's a terminal here. You know there is another terminal here. Right? So terminal will come here. And then terminal will come here. You know the flow has to go downwards. And what's going to happen in the center? What's going to happen? Yeah. Huh? There's a terminal. Well done. Okay. There is a terminal. And what is the direction? Terminal 1, terminal 2, terminal 3, terminal 4. Once you see this, then you can determine your what? Don't see this, nothing. Right? Now, any of you, are you surprised of how they feel? Yes. Yes. Because T1, once it reaches the vertical web, it has to flow down. From T2, it also has to what? Flow down. If you look at the first moment of area, is V times Z multiplied by Y bar. The Y bar, there is a Y bar distance, yes or no? The in between. Right? I'm talking about this distance. I'm talking about this region. It cannot be equal to 0. There's only one spot equal to 0 is at the terminal. Once it goes away from the terminal, you don't have to. Yeah, that's not terminal because they flow down. Yeah, terminal means what? The word terminal from the word Greek, I'm bullshitting. I know nothing about Greek. Terminal means what? End, right? If someone, the doctor tell you your life is at its terminal. Oh yeah, tomorrow I see Jesus. Yes or no? Okay? So now, where the two meet and come down, it's not a what? Terminal. What is it called? A junction. Let's not get too much in all this stuff. Everyone get confused. We just learn about terminal. Are we clear? Right? Makes sense, yes or no? We all understand what? Okay. Now, I think point A is real easy. At point A, this is our point A. What area do we take? The small area, yes or no? Why the small area? Because remember one of the point we say, it has to be closest from the what? The terminal. Make sense? Logical? No, closest from the terminal. So for A, we are going to take the terminal over here. Now the question for you is B. Now A, is it a white flange or box B? Yeah, white flange because there's only one Q. The terminal did not split into what? Q. Now, at point B, let's say now I don't give you all these. I give you a lot of rules. But up to 7. Now, if I don't give you the rules, what are you going to consider at point B? Confusing like crazy, yes or no? Right? It gets very long. So now you come to your mind, right? You come to your mind, mathematically, the first moment of area cannot cross the what? Cannot cross the centroid. So we know that this is the what? This is the what? So about here, okay, so the distance from here to the centroid is 2.8362. I'm not going to waste time looking for all these values because all of you should know by now. Right? So at point B, centroid, let's focus on the bottom box beam of white flag. Right? Box beam. Now the question next one is, what area do you take? What area do you take? You take the area now that is closest to the what? To the terminal. So it's closest to the terminal is which one? T1. There's only one terminal there. You cannot take T1, you cannot take T3, you cannot take T2. Why? Because it's above the terminal. And what do we say about above the centroid? The first moment of area cannot cross the what? When doing this, you're like a lawyer in a court case. You prove all the positive and you deny all the what? Negative. You break any of these rules, your analysis is down the toilet bowl and you go to jail. Yes. We're clear. So for point B, where do we take? Evans! Point B, Evans will say, shit, I'm not going to be in his class anymore. He can just remember my name. Hey? No. Okay, let's forgive Evans. Danielle! No. Okay, random name, okay? What? I just shout those names randomly. That's the aim. And also, you also comply the rule that the analysis has to start from where? Maximum distance away from the what? From the centroid. Cannot break any of those rules. Now, you look at any big wall, thin wall analysis, I can throw any textbooks to you, even published in the 30s, you can solve every problem. Are we clear? Okay. Yes. Box spin. One part go to left, one part go to right. Okay. Hey, this is not that difficult yet. You know what's the difficult part? Later on, when we combine shear stress, normal stress, torsion, you have to nail this. Okay? If you don't nail this, you're in a big of trouble. So now we know that this is our what? So once you know what area to consider, is it easy peasy, squeezy, and limey? That's what my daughter always tell me. Dad, it's easy peasy, squeezy, and limey. Don't understand what it means, but that's what she says. Okay. So let's do this example just based on the first moment of area. So just find the first moment. So we are going to consider point A, and point A is white flange. White flange, you only need to call this at 2, or you only call this Q. Okay, so Q, first moment of area at point A, about the z-axis, about point A, width, depth, y bar. So the width is what? 2 inches. The depth is what? 0.5. The Y bar. Evans, you're on holiday today, okay? I'll make sure not to call you again. My pleasure. But you're back on Friday.
2.8362 minus 0.5 divided by 2 times by 0.5 times by 2 is equal to 2. I get 2.58. Did I get 2.58? Yep, 2.5862. Okay, inches cubed. And then we're going to find what does it want us to find? Okay, the shear stress at point A. So the shear stress at point A is equal to the V. V is equal to 7 times 10 to the power 3. I, okay, so I is also given, okay? I'm not going to spend time looking for I. Yes, sir. Hey? What? Oh, shear flow. Okay, thank you. Too excited again. Muchas gracias. And then the is 92.569 for the first moment of area. Second, sorry. And then over here is 2.5862. Okay. So 7 power 3 times by 2.5862 divided by 92.569 is equal to 195.567. Okay, is equal to 195.567 Newton per meter. So the next one, we consider point B. Yes. Oh, yeah. Come and get more orange juice for me, okay? Thank you. And the one before, you can get another pint. Consider B. B is known as the what? Box beam. And now this is equal to what? 2Q. So QZ at point B, the width is equal to 6. The depth, no, 7. Okay, it's because 6 plus 0.5, 0.5 is equal to 7. The depth is equal to 0.5. The Y bar is now what? 6.5 minus by the Y bar is what? 2.8362. 2.8362 minus by 0.5 divided by 2. Why that's the case? Because the distance from here to here is 6.5 minus by 2.8362. Then you take halfway at 0.5. That's the reason why. So this will be equal to 6.5 minus 2.8362 minus 0.5 divided by 2 times by 0.5 times by 7. 11 point, did I get 11? 11.92.3. 9483 inches to the cube. And then finally, your shear flow at B is equal to 7 times 10 to the power 3 divided by 92.569, 11.9483, and you have to divide by 2 because it's what? Box beam. Okay. 10 power 3 times by 11.9483 divided by 92.569 divided by 2 is equal to 451.76. Pound inch. Okay. Now, the question even asks further that we have to determine the location of the maximum flow, shear flow in the what? Cross section. Okay, I'm going to use this. I'm going to see. I need these values. Okay, so we are now. I know I should not do this. You know what? I'm going to do this. I should not do this. I'm going to do this. Some of you are confused like crazy. So I'm going to move this across over here. Now, the next part, I'm a bit worried. Let me tell you why I'm a bit worried. We are now going to find the maximum shear flow. Am I out of time? Okay, we come back again. Then we do the position of the maximum shear flow. Thank you.